In this video we are going to study about divisibility rules. Number divisible by another number if the remainder is 0. Which means when you divide 36 by 9, the result is going to be equal to 4. This is the quotient. 4 times 9 is 36, and the remainder here it's going to be equal to 0. If there is no remainder, if the remainder is 0, if there is no remainder also, it means that number is divisible. So we are going to say like this: 9 is divisible by 36. I made a mistake here. 36 is divisible by 9. And here we are going to try to understand numbers divisible by 2, 3, or so on. Here the numbers are written here, and we are going to try to understand by using the rules here. Only we are not going to learn by 8, and we are not going to learn here by 12. I'm not going to explain. These are okay. In this video only we are going to learn 2, 3, and 4. Then the rest of them, they are going to be in the other videos. Okay, here I want to continue with the divisibility by 2. Divisibility by 2, number divisible by 2 if the number is even, or if it ends, the last digit must be 0, 2, 4, 6, or 8. So when I check the numbers, here there is exercise. When I check the number, I'm checking only the last digit. So I'm going to check this number, this number, this number, this number, and this number. If it is one of them, 0, 2, 4, 6, or 8, I'm going to say this number is divisible or not. Okay, the A1 I'm checking 108, the last digit is 8, so it is divisible by 2. The B1 is divisible by 2 because the last digit is 6, and here it is 6. And the C1 is divisible by 2 because the last digit is 2, and here it is the one of the member of this group. And the D1 is not divisible by 2 also because the last digit is here 1, and the last one, the E1, sorry, not the F1, E1, E, the last digit is 0, so it's the member of this group, so divisible by 2. So we can also we can say like this: when the numbers ending with 0, 2, 4, 6, and 8, it's called even number. Divisibility by 3 now. Rational number divisible by 3 if the sum of the digits is divisible by 3. Here, when you want to understand the number is divisible or not, you should find the sum of the digits. So, if we are checking 7605, we should add the digits. Then, actually, this is AI 7 plus 6 plus 0 plus 5. And when I check the numbers, 7 plus 6 is equal to 13, and plus 5 it's going to be equal to 18. So number is divisible by 3 because 18, when you divide by 3, the result is 6. It's going to be equal to here 18, and the remainder is 0. So when there's no remainder, it means that number is divisible. So if number is divisible by 18 divisible by 3, it means that 7605 divisible by 3. By the way, I want to mention another here, another trick here. 18 is divisible or not. If we cannot directly understand, we can add 1 and 8, and the result is 9. We know that 9 is divisible, so 18 is divisible, so 7605 is divisible. We can get this result. Okay, the second one is here 42,000, but we are not going to write the number, we are going to add the digits on them. 1, 4, and 5, 42,145. it's going to be, the result is 6 plus 1, 7 plus 4, it's equal to 11 plus 5 is equal to 16. If the number is 16, it means that the number is not divisible by 3, because 16 is not divisible by 3. The last one here, it's difficult to read, but here units, then thousands, then millions, then this is billion, and this is trillion. So 555 trillion, 555 billion, 555 million, 555 thousand, 555, it's going to be. But instead of reading this number, we are going to try to understand this is divisible by 3 or not. I wrote the number here again because I want you to see the groups here that makes 15. So this is 15, this is 15, this is 15, and this is 15 also. Here, when you treat 5 of them, 5 times 15, we have 5 times 15, that makes is equal to 75. Is 75 divisible by 3 or not? If you cannot understand easily, you can do this one. I explained this one to you. 7 plus 5 is equal to 12, and we know that 7 plus 5 is 12, and 12 is divisible by 3. So 75 divisible by 3, and the number 555 trillion, 555 billion, 555 million, 555,000, 555 is divisible by 3. Okay. Now I'm going to solve the second exercise, and the third one, it's going to be classwork for us. Classwork, it's going to be, we're going to solve this question in the class. And here I want to explain one special case in the second part. If this number is divisible by 3, what are the possible values of m? It's asking. First, it's written here, m is 5m, 3 is 3-digit number, m is digit. So possible m values are 0, 1, 2, 3, 4, 5, 6, and 7, 8, and 9 it must be, because all these are there called digits, numbers made up these numbers. That's why we are going to try to understand which number is divisible by 3. When you try the numbers, we are going to understand that one. Which means I'm going to try all the numbers one by one, and I'm going to try to understand if m is equal to 0, is the number divisible by 3 or not? If the m is equal to 1, is the number divisible by 3 or not? I'm going to try to understand this one. Okay. Now, if m is equal to 0, our number, it's going to be 5m3. 5m3 is going to be equal to 503. And the sum of its digits, 5 plus 0 plus 3, and which is equal to 8. And 8 is not divisible, so not divisible by 3. Okay, the second number is 513. 513, 5 plus 1 plus 3 it's going to be, and it's equal to 9, and this is divisible by 3. So 513 can be digit of a number, and I can write here 513 is divisible by 3, m can be equal to 1. And the second one, m is equal to 2, can be 523, the number it's going to be, and 5 plus 2 plus 3 is equal to 11. It must be, because I'm increasing only 1 here, and this number is not divisible by 3. M cannot be equal to 2. M is equal to 3. Here 533, 5 plus 3 plus 3, it's equal to this number. I made a mistake, sorry, this is 10. and this is going to be 11, and this is not divisible by 3 also. Here m is equal to 4, then it's equal to 5, 4, 3, 5 plus 4 plus 3, that makes 12, and divisible by 3. Now, as you understand, 8, 9, 10, 11, 12, the sum of the digits are increasing by 1 when you try the digits like 0, 1, 2, 3, 4, and it's obvious that if it is divisible, if it is equal to 9, divisible, if it is 12, it's divisible, the next number it's going to be equal to 15, which means m is equal to 7. 1, 4, 7, it's going to be 5, 7, 3, 5 plus 7 plus 3, it's going to be equal to 5 plus 7 plus 3, it's equal to 15, so divisible by 3. The next number m is equal to 10, but m cannot be 10 because it's not m. 10 is not digit. 10 is not digit. That's why m cannot be equal to 10. So the possible m values are m is equal to here 1, 4, and 7 is going to be. Okay, let's continue with the divisibility by 4. Here the last 2 digit is 0, 0, or the multiple of 4, it's written 0, 0, or 0, 4, 0, 0, 0, 4, 0, 8, or 12, or 16, or multiple of 4, it's going to continue with 20. Here, if the number ends with this number, then it's divisible. If I write here 1 and this number becomes 100, so this is divisible by 4. And if I write here, let's say 52, 500, 2004, it's going to be, and this is divisible by 4 again, by 4. And if it is the last 2 digit is the multiple of 4, then it's going to be divisible by 4. And here, as you see, these are the possible, the possible multiples: 0, 8, 12, 16, 20, and it will continue 24. It will continue like that. Okay, here there is an exercise, and try to understand when the number is divisible by 4. Here, last 2 digits, of course, it's not given. One of them is not given, and it is written here t is digit, which means t is element of this set: 0, 1, 2, 4, 3, 4, 5, 6, 7, 8, and 9. And here 18,700, and if t is equal to 0, it's going to be 18,706, and this number is not divisible by 4. If t is equal to 1, 18,716 is divisible by 4. T is equal to 2, 18,726, not divisible by 4. Here I forgot to put the points. And t is equal to 3, 18,736. Last 2 digits here, they are important, as you understand from the property divisible by 4. And as you see, when the t is equal to 0 or even number, it is not divisible. When it is odd number, it is divisible. So t values are going to be 1, 3, 5, 7, and 9. As I explained before, this t cannot be greater than 9 because it is digit, and the maximum digit value is 9.